Edexcel, June 2017, paper 1. Okay, so let's get started with question 1. So this is a table question. Table questions are notorious for just being difficult to process, difficult to actually understand what it's asking you, but let's see how this one goes. So the table shows market data for e-cigarettes. The original equilibrium price is £23. That might be relevant, so I'm going to underline that. But they haven't actually asked me the question yet, but I'm just trying to figure out what's actually going on in this table. So we have prices, quantity demanded per month, which is in thousands. So we have quantity demanded, we have quantity supplied per month. Okay, and then we have new quantity demanded and new quantity supplied. So we just have to work out I'm guessing, we don't know the question yet, but they're going to give us some change and we're going to have to work out the new quantity demanded, new quantity supplied. And just keep in mind, guys, it's in thousands. But yeah, let's read what the question is actually asking us. So before reading this, I am actually going to read the question because it's going to give you more context, and that's something I'd always suggest you do. Read the question, and then read the because this is going to tell you how to answer it basically. So read the question so you kind of know what you're looking for in there. So if I read this straight away, I'm going to underline things, but I'm not going to know what I'm looking for basically. So let's read the question first. So calculate the new equilibrium price and quantity following the successful advertising campaign and the fall in production costs. Use the last two columns. Okay, so I'm calculating the new equilibrium price and quantity. Okay, so but let's now read the stimulus thing we have. So as a result of a successful advertising campaign, demand increased by 3,000. Okay, that looks quite relevant. At all prices. Okay, demand increased 3,000 at all prices. So now what I'm actually going to do to make this a bit easier, I'm going to go back to my table. I'm going to do something like this. So demand increased, so increased 3,000 at all prices. Okay, so that will give me a good little annotation there. And then at the same time, production costs fell, leading to an increase in supply of 1,000 of cigarettes at all prices. Okay, so production costs fell, lead to increase in supply at all prices. So that's going to lead to 1,000 more at each price. Okay, so now let's actually tackle the question. So like I said, these questions are sometimes a bit hard to interpret. So it's just about trying to rack your brain around them. And it's just practice, honestly. The more you do, the better you'll get at them, because you'll actually kind of understand, because they all are very similar. They all kind of ask the same thing. So as the question says, we have 3,000 more quantity demanded at every price, and we have 1,000 more quantity supplied at each price. So let's work out the new quantity demanded and the new quantity supplied. So the new quantity demanded will just be so 5 plus 3 is 8, and then the new quantity supplied is going to be 10. So I'm just going to work down this table, so this should be quite simple now. 9 and 9. Okay, that looks like it actually is the answer, because it's asking us to work out, if you remember back to the question, calculate the new equilibrium price and quantity following the successful advertising campaign. So it looks like we have actually got that, but let's just fill in the rest of the table just for completeness. To 7, so that's 10, and that would be 8, and then we have 11, and we have 7, and then we have 12, and we have 6. So that is the table completed. Now let me just go back and look at what the question's actually asking me. Calculate the new equilibrium price. The new equilibrium price, obviously, what does it mean by equilibrium price, by the way? Where do we find equilibrium if we think about a supply and demand curve? So price, quantity, supply, demand. Where is equilibrium? Equilibrium is at that point. And what does that point mean? It's where the two curves intersect. Where the two curves intersect, the quantity supplied is equal to quantity demanded. So the same quantity. So that is why £24 is going to be the equilibrium price. So I'm just going to write that. £24. And then what else is asking me? So calculate the new equilibrium price and quantity, and the new equilibrium quantity would be 9,000. Remember, the units, like I said earlier, they are in thousands, 9,000. I don't think there's anything else right there, to be honest. And that's pretty much it. And that would get you 4 marks, because you remember, it is a calculate question. There's no marks for economics theory. There's no marks for anything like that. It's just about calculating what they've asked you to calculate, and they've asked you to do 2 things here. So equilibrium price and quantity, and that's pretty much it. And then perfect. And that would get you 4 marks. Do not dwell on this. Do not spend any longer trying to add economics theory because you think you need to, because it's an economic exam. No, if the questions command word is calculate, all you need to do is give them numbers they're asking you and move on. Moving on to 1B is a multiple choice question, so let's have a read of it. Research conducted in New Zealand estimated cross elasticity of demand. So that tells me XCD straight away is probably going to be used. For e-cigarettes, remember, what is XCD? Cross elasticity of demand. You're comparing 2 goods, so one of the goods is probably going to be e-cigarettes. Cross elasticity demand of e-cigarettes to be 0.16. That's given me probably something I need. In response to changes in the price of tobacco. Okay, changes in the price of tobacco. So they've given me the two goods here, I'm guessing. So e-cigarettes is gonna be one of them, and changes in the price of tobacco. Let's write out the XCD formula quickly because it'll probably make it a bit easier. So percentage change in quantity demanded of good A, or like whatever it is, of good A divided by percentage change in price of good B. Okay, let's read the rest of the question. This implies that there's a 5% increase in the price of tobacco. That's probably another stat we're going to have to use. 5% increase in the price of tobacco, which will cause the percentage change in quantity demanded for e-cigarettes to be. Okay, so now this sounds quite complex, but let's break this down let's read it again from the start. So we've highlighted the important parts, which is a good thing now. So let's just basically read what we've highlighted. The XCD of demand for e-cigarettes is 0.16. So they've told us the XCD value. So let's get that down. So 1.6, we're basically filling in our formula. And there's a lot of these types of questions where they get you to basically manipulate the formula. So now, we've got the XCD value. Let's keep reading. Response to changes in the price of tobacco. So we're talking about the price of tobacco. So now, if we look at the XCD formula, there is a very small technicality with it. So it's percentage change in quantity demanded of good A divided by percentage change in price of good B. So if we're talking about price, we must be talking about good B. So in response to change in price of good B, so now it then tells us the value which price changes. So there's a 5% increase in the price of tobacco. That means that is going to fill in the bottom of our formula. So now basically what the question is asking you is asking you this value. So it's asking you X. So what does that value equal? Now the way you calculate that is just, it's like GCSE maths. I don't have my calculator with me, so I have to use my phone, but the way you calculate it is just 0.1, I can't type, is 0.16 times 5, and then that would give us 0.8, and 0.8 is obviously C, which will be the answer here. So like I would do, so 0.16 times 5 equals 0.8, and that would be the correct answer. Okay, so moving on to question 2. So let's have a read of this question. Again, I'm going to start with the actual question and then go on to the stimulus. So assume that the change in the quantity of tea purchased was only caused by a change in the price of tea. Okay, so that's just an assumption. I don't think I'm going to have to use that. So calculate the PED. So it's asking me PED. Let's get that written down just for the video sake. So percentage change in quantity demanded divided by percentage change in price. Okay, so calculate the PED for tea in response to, so basically all this question is asking you is calculate the PED. So so this will now tell us how to calculate it, well, the numbers to use. So between 2010 and 2015, the average price of tea increased from £7.20 to £8.48 per kilo. So we increased from £7.20, and remember, to calculate percentage change, you need the change. So percentage change is change divided by original times 100. I must really be annoying some A-level maths people here. But yeah, so let's calculate the change. So the change would simply be, if we do it on our calculator, it is £8.48 take away £7.20 divided by, because remember, we increased from £7.20 to £7.20 is our original, and let's quickly calculate that on the calculator. Okay, so the change there, it is, as it shows, it's £1.28, and that £1.28, what am I going to do to it? I'm going to divide it by £7.20 here, which is going to give me the value of 0.17. So 0.178, I'll say, just to round it up. So 0.178, what is this now? This is the percentage change in price. So if you remember back to the PED formula, price is at the bottom. So I'm just going to slap that in the bottom there. So 0.178 divided by, now we still need to calculate the top value, which is percentage change in quantity demanded, and I think that says this later on. So over the same period, the quantity of tea purchased fell. So the quantity of tea purchased fell, which means the value should be negative technically, but a lot of the time, or most of the time, Edexcel, they don't actually care whether you give the PED value negative or positive, but that's besides the point. Over the same period, the quantity of tea purchased fell from 97 million kilos to 76 million kilos. And again, it's just about, the reason why I just read this slightly attentively, you want to get the original right, because if you don't get what was original right for the percentage change formula, you're going to mess the entire thing up. So the tea purchase from 97 to 76. So remember, if we fell from 97, 97 must be the original. So then I will just work that out. Let me slap down my calculator. And that has given me the entire equation, has given me 0.216. So now this is my PED. And let's just divide them up. So 0.216 divided by 0.178. And that is going to give me a nice whole number value of 1.216. So I'm just going to round that up to 1.22. And that is my PED value. And that is 2A done, so let's move on to 2B. So calculate the change, so change in total sales, so we're talking about sales here, so total sales revenue actually. So calculate the change in total sales revenue for UK tea retailers between 2010 and 2015. Okay, so in 2010, if we're trying to work out sales, like I said, price times quantity, in 2010 our prices were £7.20 and our quantity demanded was 97 million, so simply 7.2 times 97 would be our first one, and then we have £8.48 times 76. Now, one thing to be careful of is the kilos are in millions, so make sure at the end we do need to add our units. So just slap them into my calculator. So the revenue is for, in 2010 is 698.4 million, and then in 2015 it was 644.5 million, and then of course, to get the answer is asking for a change. It's a simple take 988 away from 644. So now if you look at these numbers, in 2010 our sales revenue was 698 million, and in 2015 our sales revenue is 644.5 million. Now what does this show? It shows that sales revenue has fallen over those 5 years. So now we need to make sure, and I'm sure one of the points in the mark scheme will be to get the full 2 marks, you will have to give a negative number. So of course 644.5 take away 698.4 will give you the last answer, and that will give us minus 53.9. And remember, we do need to include our unit, millions. You can say whatever, change in total sales, and that is our answer. I just want to make that clear to the examiner, and perfect. That is all you need for that question. 2C is a little multiple choice question. So estimates for the demand of black tea in the UK suggest it is an inferior good. This implies the good has a negative, and it's giving you basically all the different elasticities of demand. So let's break this down. So cross elasticity demand, what is that to do with? Cross elasticity demand is to do with substitutes and complements. So it's not really to do with inferior goods, so we're going to get rid of that. We'll skip past B. PED is to do with price and just quantity demanded. It's not to do with that, and same with PES, is to do with price, quantity demanded. Then what is Y? So income elasticity demand, or more commonly known as YED. What is YED to do with? Is to do with inferior goods and then normal goods. So yes, the answer for this would be B. Moving on to question 3. And just looking at it, I can just tell it's an absolute classic, and I can't even start to tell you how many students drop marks on this. But let's get started. So starting with actually reading the question, calculate the domestic cooking subsidy. So subsidy paid daily by the Indian government. So we're trying to work out a subsidy amount. Now, what is a subsidy? It's a grant to producers, basically where the government gives money to producers to produce more. The main things I'm going to catch you out with these diagram questions, look at the axes. So this price per cylinder is in rupees, and then the quantity of gas cylinders is daily, and it's in millions. So that's a big one. So always look at the units. So reading the stimulus, it doesn't give me much. So yeah, there's no need to read the stimulus. So basically, what's the question asking me? Work out, calculate the subsidy amount paid daily, and that's all they want. It's another calculate question. So the way we do this is take 1023, which is a price here, take that away from 455, which would give us, on my calculator, this would give us 568 rupees, and I would then divide that, I would then times that by 1.8, but then of course, because that's the quantity of cylinders, so I times that by 1.8, but that would of course be millions, and then that would give me my answer. So my answer would be 10224 million, and that is the subsidy paid daily by the Indian government. Alright, so I'm sure a lot of you are quite confused, so I went through that entire thing without any explanation on purpose, but now let's actually get down to explain it. So the Indian government want to subsidise these gas cylinders for Indian firms to produce more. They want them to increase their production from 1.5 to 1.8, and that is the main thing. They want them to increase production. But simply, for an Indian firm to produce 1.8 million cylinders before the subsidy, what price do they want? And how do you get that? So before the subsidy, to produce 1.8 million cylinders, the Indian firm wants 1,023 rupees. And that is the reason why we use this number, because this is the price the Indian firm wants before the subsidy. So 1,023 rupees is the price per cylinder an Indian firm wants to produce 1.8 million quantity of gas cylinders. So there we were focusing on the supply curve. Now let's look at the demand curve. At 1.8 million cylinders, how much do consumers want to pay? So we go from 1.8 million, we go up to the demand curve, and that is exactly 455. Now, that is where we get the numbers from. Let's think about this. Firms charge 1,023 rupees at 1.8 million quantity of gas cylinders. Consumers only want to pay 455 at 1.8 million. So who covers that difference? That is the government, and that is the subsidy. So that's why we take away those two numbers to get us 568, which is the subsidy per cylinder for the government. And as we know, there's 1.8 million cylinders, so we times them together, which will give us 1,022.4 million that the government is paying every day in a subsidy. This is a bit of a trickier question than other Section A questions, but if you just understand the basics, at 1.8 million, firms want to charge 1,023 rupees, but also on the opposite side of the spectrum, at 1.8 million units, consumers only want to pay 455 rupees. And remember, we're talking about subsidies, so who has to cover that gap? Where is that discrepancy? How is that discrepancy going to be matched? That is the government, and they're going to provide that quantity of subsidy. Okay, so let's tackle the rest of this question. So calculate the percentage change, which sounds quite important. Percentage change of the total subsidy received by consumers and producers. So of course, subsidy is going to affect both consumers and producers, so let's work this out. So total subsidy, we have already worked out the total subsidy, which is this number here. So that is 568, because remember, this is just timesing it by the quantity. This is the actual amount daily paid by the Indian government, but this is the actual amount of the subsidy. Okay, so we have already calculated the total amount of the subsidy, which would be 568. Now we just need to work out basically how much the consumers got, and then we can use that to work out how much the producers got. So if we look at consumers, let's just work out the difference. So 526 take away 455, and it would be great if I had a calculator. That would give us 71, so what I'd do, so it's just 71 divided by 568 times 100, and if we work that out, which I cannot, would give us 12.5%. Now, what you can do to make it really easy, if consumers receive 12.5%, all the rest must be producers. So if you take away 100, take away 12.5%, it means producers are going to receive 87.5%. Okay, so moving on to the last bit of this question. One effect of a subsidy is do subsidies increase consumer surplus? Yes. Do they increase market failure? It's the opposite. Why do we implement subsidies? Used usually in positive externalities, where we want to encourage the consumption of goods with positive externalities. So they do not increase market failure, they try to reduce market failure. So public good provision. Do we use subsidies for public good provision? No, it's usually state provision. And then one effect of subsidies to increase tax revenue? Not quite. Subsidies actually use up tax revenue, which is wrong. Therefore, the answer would have been A. Okay, moving on to question 4. Draw a cost and revenue diagram, which is basically the way I think about cost and revenue diagrams. I just think about a monopoly diagram, but that's just how I remember it. But yeah, cost and revenue diagram to show the likely impact of a reduction in sales on a basic construction equipment JCB's profits. So a reduction in sales on a firm's profits. So if we think about sales, what is a reduction in sales going to cause? What is it going to affect? A reduction in sales is going to affect demand, isn't it? So it's going to affect our demand equals AR curve, and then because it affects our average revenue, it will also affect our MR curve. So they are the two curves that a reduction in sales will affect. If we think about this R word, what does R stand for? R stands for revenue. So in demand equals AI stands for average revenue, and in MR it stands for marginal revenue. And how do we get revenue? What is the formula for revenue? Revenue is sales times quantity. Therefore, if we have a reduction in sales, that means obviously we're going to have a reduction in revenue. But yeah, let's get started here by drawing a monopoly diagram or a cost and revenue diagram, however you call it. So cost / revenue on your y-axis, revenue, and then quantity on your x-axis. And let's get a monopoly diagram drawn, or a cost revenue diagram, whatever you want to call it. So I always start with my D equals AR, so demand equals AR. Then we have our MR curve, which is twice as steep. Then we have our AC curve. And what is the only rule with the MC curve? The MC curve needs to intersect AC at its lowest point. So something like that does suffice. And now we're talking about a reduction in sales affecting a firm's profits. So let's just quickly label up JCB's profits here. Where do firms profit maximize? Profit maximization occurs where MC equals MR, which is that point right here. And then how do we work out a firm's supernormal profits? We go from MC equals MR, we keep going up until we hit our AR curve. And when we hit our AR curve, we go left from there. And that will tell us a price at where we profit maximize. So I'm going to label that P max now, and then go down from that point to give us Q max. But now, how do we find that box of supernormal profit? We go up from that Q max quantity and we keep going up until we hit our AC curve, until we hit our costs. So let's label that up there. And now this will be our box of supernormal profit before a reduction in sales. And why is that the box supernormal profit? Because this tells us the price they sell at, and then this tells us the costs. So anything above the costs is the profits. But now let's work out what happens after a reduction in sales. So how would I show that on a diagram? Like I said, we're going to shift two curves in, which is our D equals AR curve and our MR curve. So let's do that here. So we'll shift that to there. So D1 equals AR1. And then we'll shift our MR curve in also, which will look something like this. So I'm going to label that MR1 now. So now that's our two curves shifted in. That's nearly all the question done. But now we just need to do the last bit, which is again looking at the impact on the firm's profits. So again, same thing, just with two different curves now. So where the firm's profit maximize, where MC equals MR. So that would be this point here. And then what do we do from there? Same thing as last time. Just basically the only reason you drop marks here is by getting confused. So you go up from the MC equals MR point until you hit your new AR curve, which is obviously D equals AR1. And then you go left from there. So that would be P max 1, I'm going to label it. And then from MR1, you would go up, well, you can label up Q max 1 as well. But then you go up to find the costs, which would just be around there. So now, what does this show overall? So a reduction in sales, therefore a reduction in revenue. How has this affected a firm's profits? As you see, this is the blue box of supernormal profit, and this is the red box. So it shows that when a firm receives a reduction in sales, their supernormal profit is going to fall. Now, I would just write a line saying that a supernormal profit would fall, just to answer the question directly after a reduction in sales. Or you can show it in your diagram. You could say like, whatever, one box is bigger than the other box. But yeah, that is pretty much enough for 4 marks. And if you get something like that, you should be quite happy, because that is a very simple question to pick up 4 marks on. But with this question, you do not want to be dropping any marks, and the only way you can drop marks is simple mistakes like axes or not labeling your curves, especially here when you're adding your new AR MR curve. You need to make sure that you add them correctly, label everything, label the box supernormal profit. Okay, and just moving on to the next question. So it's a multiple choice question. So let's have a read of this. In India, JCB has a strong brand image, and 50% market share. So that's kind of maybe a telltale sign or something. So 50% market share in construction equipment. This means that the construction equipment market in India is likely to have a low level of... Okay, so we need to complete this statement basically. So it's likely to have a low level of concentration. So the construction equipment in India is likely to have a low level of concentration. Well, the stimulus directly contradicts that, saying that JCB has 50% market share, which obviously shows very high concentration, so that's wrong. Then we have B, which is contestability. So this means that construction equipment in India is likely to have a very low level of contestability. I agree, because of the same reasons last time. JCB has 50% market share, which could indicate there is very low levels of contestability. It's very like monopoly power-esque. C, Construction equipment in India is likely to have a low level of private ownership. In both of these stimuluses, it says nothing about private ownership, so that's not a conclusion we can take. And then it's likely to have a low level of specialization. Again, doesn't mention anything. Specialization obviously is kind of just nothing to do with this. So yeah, for this question, my answer would be B. Moving on to question 5. It looks like we've got a cup of coffee in front of us, but let's go straight to the question. Let's not waste any time reading this. We'll read it when it becomes relevant. Let's go straight to which of the following is a fixed cost to Starbucks. Now this is very simple content knowledge, so it's just the difference in a fixed and a variable cost. Variable cost, of course, vary with output. So something like coffee cups. As the more coffee you sell, the more coffee cups you'll need, whereas fixed costs do not vary with output. So let's try onto this. So coffee is going to be a variable cost, so we're going to say no. Milk is also going to be a variable cost. Packaging is also going to be a variable cost, and therefore the answer has to be rent. And why is rent a fixed cost? As if Starbucks sell one coffee versus if they sell 1 million coffees this month, the rent for that shop is not going to change. So it's not varying with output, therefore it is a fixed cost. Moving on to the next question. So this is question 5b. Explain the difference between a fixed and a variable cost. And that is basically exactly what we've just said, just define. So fixed costs being costs that do not vary with output, then variable costs being costs which vary with output. I've just written fixed costs do not change with output, whereas variable costs can increase or decrease. So basically, variable cost can vary with output. Moving on to 5c. So I know last 2 marks here for section A. So with reference to figure 1, calculate the profit in pence, and I can just tell straight away that's going to be a big thing, because if it's asking you specifically for some units, always make sure you remember that, because that is probably where most people will drop a mark. But yeah, let's see. To calculate the profit in pence for a cappuccino drink, you are advised to show your workings. So this is why I advise to go straight to the questions, because now we actually need to use this. I'm guessing this bit. We need to use this bit of the extract. But if you read that straight away and then you go on to answer these 2 questions, by the time you get to 5c, so this question anyway, you're going to have probably forgotten it. It's just a waste of time. So only read things when you need them, when it's relevant. So 5c, calculate the profit in pence for a cappuccino drink. So first, if we read it, if you look at the start of it, it tells us the price of a cappuccino drink, which is £2.27. But now, if you remember what I was saying earlier, it says calculate the profit in pence. So if it's £2.27, that means this is 227 pence. Since of course there's 100 pennies in a pound. So now let's calculate the profit. So what does this show us? So this shows us all of the costs, I guess. Okay, so at the bottom, they tell us there's 13% profit. So that should be quite easy now. So how are we going to calculate the amount of profit from this £2.27? What we are going to do, we're going to take 227, we're going to divide it by 100 and times it by 13. And that should give us the profit Starbucks makes from each cappuccino drink in pence. So I'm just going to make sure to give it the pence sign, and that would be my answer. That's all you need to do for section A. So that is how to get 25 out of 25 on your section A. Now, of course, I've been doing economics a lot longer than you guys have, so it comes quite easy to me, but I've seen it with my students. All you need to do is practice. So try to get through, especially before your paper 1 and paper 2, try to get through every single section A. Wherever you drop a mark in section A, try to analyse, understand why you dropped that mark, and then next time make sure you do not drop that mark. And that just constant repetition, that constant cycle of rectifying your mistakes should hopefully, in your real exam, get you to those full marks or somewhere near full marks. As you remember, section A questions repeat all the time, so you really want to make sure if you drop a mark, you understand why you dropped it. So next time, if that comes up in your real paper, you are not dropping that mark.